Hello students, welcome to PYQs. So in this video we're going to cover electricity previous year important electricity chapter important formula and numericals of previous year questions. So we have total 5 main important formulas. In the previous live session there is some mic issue due to which there is some audio issue with respect to my mic, so due to which I'm sorry for it. So let's reconduct the same session again with the proper audio and something. Okay, so let's start with the video again. So first thing, as I mentioned, important formula. So what is the important formula? First one is charge. Q is equal to IT, where Q, that is charge, is mentioned in coulombs. C, I, current in amperes, symbol is A, time in seconds, symbol is S. Okay, then we have Ohm's law. V is equal to IR, where V is voltage, symbol is V, I in amperes in A, and R in ohms, V proportional to I. So what is Ohm's law? Means voltage across any conductor is proportional to the current passing through it, where R is the proportional quantity, which is resistance. Okay, then we have series and parallel combination formulas. For series resistance, R effective is equal to R1 plus R2, whereas parallel resistance 1 by R1 is equal to 1 by R1 plus 1 by R2. Then we have power formula. Power is equal to V into I, or I square into R, or V square by R. Then we have energy formula. Energy is equal to power into time, that is power formula we already know, which is VI, I square R, or V square R. So same apply here, you will get I square RT, V square by RT, or VIT. Okay, then we have the last, which is resistance formula in terms of resistivity, length and area, which is rho L by A, where rho is resistivity, it only depends upon material. Length, as you know, which is the length of the conductor in meters, and area of the cross section, mostly to meter square. Okay, let's solve few numericals. First one, find the current flowing through the following electric current, and which are the numericals I am discussing in this video are directly from the previous year, that is 2024 question paper in various sets. So based upon the set, I have took few questions and we are going to cover all those questions in this video. Okay, so this question, this see 3 is there, and we have 6 ohms, and we have 2 resistors in series here, and this is another resistance. So if 2 resistors are in series, what is effective resistance? It should be R1 plus R2. So this circuit I can rewrite it as 3 ohms, 6 ohms, and this are in series, so those two I have combined, you will get 6 plus 6, which is 12 ohms, and again 3 ohms, and then is a cell which is 4.5 volts. So now 6 and 12 are in parallel, so R 1 by R effective is equal to 1 by 6 plus 1 by 12, which is, if I take LCM, it becomes 12, 6 2 is 12, 2 plus 1, which is 3 by 12, 3 by 12, 1 by R is 3 by 12, so R is equal to 4. Okay, so now the third circuit will be, we have 3 ohms, this is 4 ohms, and we have another 3 ohms in series, so this will be 3 ohms again, and this is connected to a circuit which is 4.5 volts. Okay, so these 3 are in series, so definitely all 3 effective resistance will be R total, I can say, which is 3 plus 4 plus 3, which is 10 ohms. So V is equal to IR. We know V is 4.5 volts is equal to current into resistance is 10 ohms. So current is equal to 4.5 by 10, which is 0.45 amperes. Okay, let's go to the next one. So they're asking to plot the graph. So plot the graph, we just take a graph sheet where we have V and I. Okay, and keep it a mark I as 1 ampere, 2 ampere, 3 ampere, and so on. And voltage, like the scale is, let's take 2 volts, 4 volts, 6 volts, and so on. So based on it, if you mark it, the first one 0.5 is 1.5. So if you give 0.5 amperes, it will be 1.5 somewhere here. Then 1 is 3. Okay, somewhere here. 2 is 6.2. If I keep this as 2, I will get 6.2 somewhere here. Okay, if you draw all the points and if you mark it, keep it as straight line, it will be a straight line passing through origin. Okay, then they are asking the plot is done. Then calculate the resistance with the help of graph. With the help of graph, the resistance is nothing but the slope. Slope is nothing but V by I. So take any resistance V by I here. Let's I'm taking the middle one, 6.2 by 2. It is 3.1 ohms. If you take other values also, it will be nearer to 3. Here it is 3, here it is 3, it is 3.1 here, and here it is 3.1 point something. So I can say R effective is almost close to 3.1 ohms. Okay, so what does the graph represent? It represents a straight line passing through origin. Okay, this is straight line passing through origin. Next, why should graph pass through origin? Because V is proportional to I. If I is 0, V is also 0. Therefore, it has to pass through origin. Okay, next, see the next question. Electric iron resistance is mentioned. Resistance is 20 ohms. Current I is mentioned 5 amperes. They're asking the heat generated, and the time as I mentioned is 30 seconds. Okay, heat is nothing but energy here. So what are the formulas of energy we studied? Energy formulas: P into T, I square RT, V square T by R, another one VIT. Okay, so based on it we have I and R, so we have to use this formula here. So energy is nothing but the heat, which is I square, that is 5 square into resistance is 20 and time is 30 seconds. So it will get 15,000 joules, which is C. Okay, let's move to the next one. We have total 4 resistors. They are asking which combination will give you 1 ohms. Okay, so if any 2 resistors are in parallel and if it is equal resistors, like suppose like this, A and A, if we have the effective resistance, it will be A by 2. If you have multiple like 3, 4, the same way it will be A by 3, A by 4 and so on. Okay, so here it is 2 equal resistors, so it will be 2 by 2, which is 1 ohm here. Here it is 3, so it will be 3 by 3, which is again 1 ohm. This combination is 6 ohms because in series, and this is again 6 ohms, which is in series. 6 and 6 in parallel, so it will be 6 by 2, which is 3 ohms here. And here it is 0.5, 0.5, 0.5 by 0.5, which is 0.25 in the fourth ohm. So which is having 1 ampere, this will be this one and this one, which is 1 and 2. C is the right answer. Okay, this is the trick. The same way if I see 3 A's are in parallel, A in parallel, then the effective resistance will be A by 3. Okay, like in this case, A is 3 here, so it is 3 by 3, which is 1 ohm. Here it is in these two are in series 6 and these two in series 6, 6 by 6. So 6 and 6 in parallel, so the answer is 6 by 2, which is 3. Here 0.4, 0.5 in parallel, 0.5 by 2, which is 0.25. Okay, hope you understood. Let's move to the next question. Find the total distance between A and B. A and B, what are the resistors? These 3 are resistors and these 3 are in series. So the effective is 4 plus 6 plus 16, which is 4 plus 6 plus 16, which is 26 ohms. Okay, let's see the next one. Find the effective resistance between B and C. This is B and C, these two effective resistance. So again same concept, equal resistance in parallel, 2 resistance in parallel. So effective will be 8 by 2. If it is 3 resistance in parallel, 8 by 3. So this answer is 4 ohms. Calculate the current generated from the battery when the key is closed. So when this key is closed, they are asking. So very simple. Sign the circuit will be total effective resistance we need to write. These 3 we already got, which is 26. And this we know, which is 4 ohms. And these 2 are in series. If 2 resistors are in series, you have to simply add them. Okay, so 6 volts is equal to 26 plus 4, which is 30 ohms into I. So I is equal to 6 by 30, which is 6 by 30 is 0.1 by 5, which is 0.2 ampere. Okay, so the current is 0.2 ampere. The above circuit 16 resistors or the parallel combination of 2 resistors which is having more potential difference. Okay, so we have one which is 16 ohms. We have the parallel combination of 2, 8, which we also got. The answer is 4 ohms. Okay, so among this which is having more potential, so V formula is I into R. So for these 2 resistors, which is current is common for both because those 2 are in series. So simply V is proportional to R here. So here this potential will be higher. So voltage across 16 ohms is higher as V is proportional to R here as I is constant. Okay, because they are in series. So if they ask the values, so it is V 16 ohms is equal to 4. What is the current we got? Current is 0.2 ampere. So 0.2 into 16, which is 3.2 volts, and here it is 4 into 0.2, which is 0.8 volts. So which is higher? 3.2 volts is higher. So voltage across 16 ohms is higher. Okay. Next one. In case of 4 wires of same material, so for this questions it is asking about R is equal to rho L by K. So same material, so rho is constant. So we have only L and A. So D is the diameter here. So area is always proportional to R square. So R is, again I can say, D by 2. So area is proportional to diameter square. Okay. So let's see for R1. R1 proportionality I am writing here because I don't want the constants. So rho is constant, leaving it. L is L by 4 now. And area is D square. So here D is D by 2. So it is D square by 4. So it is simple L by D square for first case. R2, 4L by D square by 16, because it is D by 4. So it is 4 into 16. It will be 64L by D square. Okay. R3, L by 2D whole square. It is 4D square. So it will be L by 4D square. Next R4 is 2L by 16D square. Okay, so it will be L by 8D square. So which is least? This one is least. Let's move to the next one. Okay, this is very interesting question and it is important, this type of circuits. Okay, so how to solve it? The trick is, first write this as E and this as B and mark it. So if any potential, if suppose I have 2 points X and Y, and if I have a short circuit like this, then V at X will be V at Y, or I can simply say X point is equal to Y point. Okay, so for this here I can say X is equal to, where it is marked, B, and A is equal to Y, or Y is equal to A. So simple, I have only 2 points X and Y. So I'll just write X and this is Y, and this is a circuit here which is having a cell and a key. So let's mark first one X to A, which is X to Y also, which is 2 ohms. A to B is also X to Y only, which is 3 ohms. B to Y, which is 6 ohms. Okay, so 3 resistors in parallel. So simple, 1 by R effective is equal to 1 by 2 plus 1 by 3 plus 1 by 6. So if I take LCM as 6, it will become 2 3s are 6, 3 2s are 6, and 6 1s are 6. So it will be 6 by 6, which is 1. 1 by R is equal to 1, so R is also 1, which is D is the right answer. Okay, let's move to the next one. Okay, this is the last question for today. Draw a schematic diagram of a circuit consisting of a battery, 4 cells each. Okay, so for battery, what you have to draw is, you have to draw in this way, 4 cells, 1 2 3 4, 4 cells, and each is having 1.5. So if I combine all 1.5, it becomes 6 volts. Okay, so then we have 16 ohm resist. Okay, 3 resistors, 2 6 and 16. So this is 2, this is 6, and we have 16, 3 resistors and 16, and a plug key. Okay, we have a plug key as well. Okay, fine. This is a circuit. And anything else? Put an ammeter to measure the circuit. Okay, ammeter and the voltage across 16. We have 2 meters. One is voltmeter, ammeter. Voltmeter is present here across the 16, and ammeter, it should be in series. So I'm just writing it as ammeter is here. Ammeter should be here. Ammeter should always be in series, whereas voltmeter should always be in parallel. Now let's solve the question. Ammeter reading. So simply asking what is the current reading. So you can see, if you notice here, these 3 resistors are in series. So if in the series resistance, what is the effective? It should be, we have to just add all of them. So it will be 2 plus 6 plus 16, which will be equal to 2 plus 6 is 8, 8 plus 16 is 24. So our total is equal to 24 ohms. Voltage, we know the total should be 6 volts. So the current is nothing but V is equal to IR. So 6 volts is equal to current into resistance. We got how much? Resistance is 2 plus 6, 24 ohms. So current is equal to 6 by 24, which will be equal to 1 by 4 ampere. We got the current as well. So current reading is nothing but the ampere readings. Therefore, ammeter reading is equal to 1 by 4 ampere. What they are asking, second one, voltmeter reading. When the key is closed, voltmeter reading is the voltage across 16 volts, 16 ohms. Voltage across 16 ohms. So voltage across 16 ohms is V is equal to I into R. So current we got, which is 1.1 by 4 into R is 16, which is equal to 4 volts. So voltage across 16 ohms is 4 volts, and current across in the circuit, that is in the ammeter in the series circuit, so same current will be flowing, which is 1 by 4 amperes. Okay, so hope you understood all the numericals. If you have any doubt with respect to any numericals, you can also clearly mention the set name of 2024 paper. So it should be in somewhere like this, like from my example which I have the reference, I will give one example, 3133. So from this paper also I have solved it. So just check whichever set you have. In this way, if you keep the in the comment and mention the question number, so that I can check, and also keep in another video where I will keep the solution of that particular question number. Okay, thanks for watching. Please subscribe, and as I mentioned, please share it to the friends so that they can also get the solution of these questions. So in the next video, I'll try to keep okay, I'll use reflection and refraction questions. So in this chapter also we have so many numericals. So in the next video, I'll try to cover these numericals. Okay, thank you. So in the next video we'll meet again.